Congratulations, you've made it this far to the last and final module. Great job. So let's get cracking on this and let's look at the fourth module, which is titled Design Infrastructure Solutions. And in this section, we are going to talk about 4 different sections. Design a compute solution, design an application architecture, API integration, design, get the verb, migrations, and design network solutions. Again, this is 25 to 30% of this exam. Big piece of the pie. So always think with the design hat on mind. If you had a scenario that you were given and you're given a bunch of information and then what's going to be the result. Not clicking the knobs, what buttons do you push, but how do you design this architecture? So let's break this down one by one. In recommending a compute solution based on virtual machines, one of the first things to be aware of is there are different machine sizes optimized for different purposes. Makes sense? While you can't be expected to recall the hundreds of different machine types, you should review this link to at least understand categorically the different types of categories as shown in the graphic and what each is good for. As an example, if you were provided a requirement for heavy graphics and rendering, you would know that the N series machines under type GPU would meet that requirement and not an H series. While an H series or high compute VM would work, its specialty is for the highest compute output and not the best graphics. After virtual machines are created, you can scale the VM up or down by changing the VM size. In some cases, you must deallocate the VM first. This can happen if the new size is not available on the hardware cluster that is currently hosting the VM. And as a reminder for these links, they will be posted in the description for the YouTube channel, and they will all be on my blog. So that's my new way of condensing those resources. All my blogs are at aka.ms/markgrimes. Many customers want to create their own golden images that they built and then have them in the cloud. We've been doing this for decades now. An Azure Compute Gallery helps you build structure and organization around your Azure resources like images and applications. An Azure Compute Gallery provides global replication, versioning, and grouping of resources for easier management. High available resources with zone redundant or ZRS accounts in regions that support availability zones. Premium storage support. Sharing across subscriptions, even across Active Directory tenants using Azure RBAC. And finally, scaling your deployments with your resource replicas in each region. With a gallery, you can share your resources to different users, service principals, or AD groups within your organization. Resources can be replicated to multiple regions for quicker scaling of your deployments. Azure Compute Gallery also allows you to replicate your images to other regions automatically. Each image version can be replicated to different regions depending on what makes sense for your organization. If this gallery is new to you, again, check out the link. Azure Dedicated Host is a service that provides physical servers the ability to host one or more virtual machines dedicated to one Azure subscription. Dedicated hosts are the same physical servers that are used in our data centers, actually provided as a resource to the customer. You can provision dedicated hosts within a region, availability zone, and fault domain. Then you can place your VMs directly in your provisioned hosts in whatever configuration that best meets your needs. Why would you use these? As an example, with my government customers, they have also compliance requirements that dictate this type of isolation. Now, what if your customer wants to save money? Again, having that architect design hat on. And of course, who doesn't want to save money? Here are 4 options to review and consider. What about Azure Spot Machines, Azure Hybrid Benefit, reserved instances, and a capacity reservation? Again, links are provided if you're new to any one of these, but let's give you a couple things to know about each. Azure Spot Machines let you take advantage of Azure unused capacity at a significant cost savings. They're great for workloads like batch jobs that can handle interruptions because If Azure needs it back, it can take it back. Note, though, that there is no SLA nor any high availability guarantees. For customers with software assurance, and many do have that, Azure Hybrid benefit allows you to use your on-premises licenses and run virtual machines on Azure at a reduced cost. Pretty substantial, too. Azure reservations help you to save money by committing to 1-year or 3-year plans for multiple products. Reservations can significantly reduce your resource costs by up to 72% from pay-as-you-go prices. And finally, on-demand capacity reservation, currently under preview, enables you to reserve compute capacity in an Azure region or an availability zone for any duration of time. Unlike reserved instances, you don't have to sign up for a 1-year or 3-year term commitment. Create and delete reservations at any time and have full control over how you want to manage your reservations. Remember good old Windows Terminal Services? Here's the cloud version. Azure Virtual Desktop is a desktop and app virtualization service that runs on the cloud. You can run Windows 10 multi-session systems or extend Windows 7 with free extended security updates. To set this up, you will still need Active Directory synchronized to an instance of Azure AD. And how do you do that? Of course, with Azure AD Connect. Then you can create a full desktop virtualization environment in your Azure subscription without running any gateway servers. It uses host pools, you should know that concept, which are collections of Azure virtual machines that register to Azure Virtual Desktop as session hosts when you run the Azure Virtual Desktop agent. All session host virtual machines in a host pool should be sourced from the same image for a consistent user experience. Then there are also app groups, which are logical groupings of applications installed on session hosts in the host pool. An app group can be one of two types, either a remote app, where users access the remote apps you individually select and publish to the app group, or desktop, where the user accesses the full desktop. By default, a desktop app group named Desktop Application Group is automatically created whenever you create a host pool. You can remove this app group at any time. However, you can't create another desktop app group in the host pool while a desktop app group exists. To publish remote apps, you must create a remote app group. You can create multiple remote app groups to accommodate different worker scenarios. Different remote app groups can also contain overlapping remote apps. Say a remote app group several times, that's tricky. A workspace is a logical grouping of application groups in Azure Virtual Desktops. Each Azure Virtual Desktop application group must be associated with a workspace for users to see the remote apps and desktops published to them. After you've assigned users to their app groups, they can connect to an Azure Virtual Desktop deployment with any of the Azure Virtual Desktop clients. In addition to the VM sizes and categories as mentioned above, there are some traditional availability options for Azure virtual machines that are also factors in designing a compute solution for VMs. If you've taken some previous Azure exams or have been in the cloud for a bit, you should be familiar with these concepts on the screen now. If not, make sure to review this link to have a high-level understanding of the following options: availability zones, virtual machine scale sets, availability sets, load balancers, understanding storage, redundancy, and Azure Site Recovery. Most of these we covered in Module 3, BCDR. You shouldn't need to know deep details in each, but just understand what each of these options are and what they do. For designing containerized applications, we'll focus first on Azure's Kubernetes Service, or AKS, Azure Container Apps, Web App for Containers, Azure Container Instances, and Azure Container Registry. Just a few things. Azure Kubernetes Service, or AKS, simplifies deploying a managed Kubernetes cluster in Azure by offloading the operational overhead to Azure. As a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance. When you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Advanced networking, Azure Active Directory, integration, monitoring, and other features can be configured during the deployment process. AKS also supports Windows Server containers. AKS lets you integrate with Azure AD to use Kubernetes role-based access controls, or Kubernetes RBAC. Azure's Container Apps enables you to run microservices and containerized applications on a serverless platform. Common uses of Azure Container Apps include deploying API endpoints, hosting back-end processing applications, handling event-driven processing, and running microservices. Individual container apps are deployed to a single container apps environment, which acts as a secure boundary around groups of container apps. Container apps in the same environment are deployed in the same virtual network and write logs to the same log analytics workspace. Azure Container Apps manages the details of Kubernetes and container orchestrations for you. Containers in Azure Container Apps can use any runtime, programming language, or development stack of your own choice. You can also use a custom Docker image to run your web app on an application stack that's not already defined in Azure. I added another great comparison link at the bottom of this slide, again, which will be in the blog, which will help to show the comparison of those options. It's a great summary of app service versus container instances, AKS, Azure Functions, and also Azure Spring Functions. Likewise, I ran across the compute decision tree, which isn't just brilliant for the real world, but also for architectural decisions on exams. Web Apps for Containers provides a flexible way to use Docker images. App services can host web apps natively on Linux for supported application stacks running custom Linux containers, also known as Web App for Containers. You can deploy an image from an Azure Container Registry as well as other repositories. Speaking of which, Azure Container Registry is a managed private Docker registry service based on the open source Docker Registry 2.0. Create and maintain Azure Container Registries to store and manage your private Docker container images and related artifacts. You log in with the standard Docker login. Images are transported of HTTPS and they support TLS to secure client connections. Use Azure Container Registry tasks to streamline building, testing, pushing, and deploying images to Azure. Azure Container Instances offer the fastest and simplest way to run a container in Azure without having to adopt a higher level service. Azure Container Instances enable exposing your container groups directly to the internet with an IP address and a fully qualified domain name. When you create a container instance, you can specify a custom DNS name label so your application is reachable at customlabel.azureregion.azurecontainer.io. A container group, as shown in the graphic, is a collection of containers that get scheduled on the same host machine. The containers in a container group share a lifecycle, resources, local network, and storage volumes. It's a very similar concept to a pod in Kubernetes. Azure's Functions is a serverless function that allows you to write less code, maintain less infrastructure, and save on costs. Instead of worrying about deploying and maintaining servers, the cloud infrastructure provides all the update resources needed to keep your applications running. I added this resource as yet another comparison chart that compares Azure Functions to Power Automate, Logic Apps, and Web Jobs. If I would consider reviewing any one of these, it would likely be to look at Web Jobs versus Functions. Like Azure Functions, Azure App Service Web Jobs with the Web Jobs SDK is a code-first integration service that is designed for developers. Both are built on Azure App Service and support features such as source control integration, authentication, monitoring with application insights integration. Again, here's a comparison chart to consider when you're choosing between Azure Functions and Web Jobs, so you may want to pause the video for a minute to take a quick look and a review. I think the main highlight here are the 4 check marks that functions show in the chart that Web Jobs do not do. Caching is a common technique that aims to improve the performance and scalability of a system. It does this by temporarily copying frequently accessed data to fast storage that's located close to the application. Azure Cache for Redis provides an in-memory data store based on the Redis software. Redis improves the performance and scalability of an application that uses back-end data stores heavily. It's able to process large volumes of application requests by keeping frequently accessed data in the server memory, which can be written to and read from quickly. An Azure Cache for Redis in the standard or premium tier runs on a pair of Redis servers by default. The two servers are hosted on dedicated VMs. Open source Redis allows only one server to handle the data write requests. This server is the primary node, while the other is the replica. Azure Cache for Redis distributes nodes in a zone redundant cache in a round-robin manner over the availability zones you've selected. It also determines which node will serve as the primary initially. Azure Cache for Redis supports zone redundant configurations in the premium and enterprise zones. A zone redundant cache can place its nodes across different Azure availability zones in the same region. A content delivery network is a distributed network of servers that can efficiently deliver web content to users. CDNs store cache content on edge servers in a point of presence or POP locations that are close to end users to minimize latency. This offers developers a global solution for rapidly delivering high bandwidth content to users by caching their content at a strategically placed physical nodes around the world. You need to create at least one CDN profile, which is a collection of CDN endpoints. Every CDN endpoint represents a specific configuration of content delivery behavior and access. To organize your CDN endpoints by internet domain, web application, or some other criteria, you can use multiple profiles. We've covered the messaging sections before in the AZ-304 exam page. Note, I did include the Compare Azure Messaging Services link at the bottom, and of course will be on my blog. That one doc pretty much covers the basics of what you'll need to know with respect to selecting the right option. But let's quickly summarize them for you. Azure Event Grid allows you to easily build applications with event-based architectures. First, select the Azure resource you would like to subscribe to, and then give the event handler or webhook endpoint to send the event to. Event Grid has built-in support for events coming from Azure services, like storage blobs and resource groups. Event Grid also has support for your own event using custom topics. You can use filters to route specific events to different endpoints, multicast to multiple endpoints, and to make sure your events are reliably delivered. Azure Event Hubs is a big data streaming platform and event ingestion service. It can receive and process millions of events per second. Data sent to an event hub can be transformed and stored by using any real-time analytics provider or batching storage adapters. Event hubs represent the front door for an event pipeline, often called an event ingestor in solution architectures. An event ingestor is a component or service that sits between the event publishers and event consumers to decouple the production of an event stream from the consumption of those events. Azure Service Bus is a fully managed enterprise message broker with message queues and publish-subscribe topics. Service Bus is used to decouple applications and services from each other, providing the following benefits: load balancing work across competing workers, safely routing and transferring data and control access service and application boundaries, and coordinating transactional work that requires high degree of reliability. Data is transferred between different applications and services using messages. A message is a container decorated with metadata and contains data. The data can be any kind of information, including structured data encoded with common formats, such as the following ones: JSON, XML, Apache Avro, or plain text. Messages are sent to and received from queues. Queues store messages until the receiving application is available to receive and process them. You can also use topics to send and receive messages. While a queue is often used for point-to-point communications, topics are useful in publish-subscribe scenarios. Important concepts for the exam, of course. As you have seen in a couple of the other slides I've shown, I'm a big fan of the comparison sheets as they give a good quick overview. When you think of cloud automation, you would think of a cloud service like Azure DevOps. But there can be situations where the old school Azure DevOps server is the answer to the question, i.e., what tool should I use? One key example to note would be if you needed integration with SQL Server Analysis Services, which is not supported on Azure DevOps services. Probably one of the most notable differences, which could be a critical architecture decision, is how they authenticate. As an example, I have a government customer with environments siloed off, and Azure Active Directory just isn't an option because they're disconnected from the internet. But with DevOps Server, you can still authenticate with an intranet server and by using Windows authentication. Therefore, if there was authentication and things like conditional access policies, Cloud MFA, etc. are required, then Azure DevOps Services would be the architectural choice. While there are many third-party tools for automation, on this page link, I would focus on the native capabilities within Azure. Just scrolling down that link, here's some things that caught my eye. Cloud Init, PowerShell DSC, Azure Custom Script Extension, Azure Automation, and Azure Resource Manager templates. For an architectural exam like this, I wouldn't expect you to know the how-tos of these options, but more so understand which one to use and why should I select one over the other. We've covered most of these on previous C.E.R.T sessions. On the AZ-304 C.E.R.T session, go back and review the third module that covers deploy and manage Azure Compute Resources. On the previous C.E.R.T session, you'll want to look at Part 2 of Module 1, Implement and Monitor an Azure Infrastructure, where ARM templates and Azure Automation are covered in the first section titled Automate Deployments and Configuration of Resources. I'll link these in the description and or on my blog when I update all these resources after the recordings. Hopefully by now you're familiar with these options, but if you're newer or need a refresher, we have these all for you. Azure Automation State Configuration is an Azure configuration management service that allows you to configure and enforce state on virtual and physical machines in any cloud or on-premises data center. In addition to enforcing configurations, you can also use Azure Automation State Configuration in a report-only mode where compliance data is generated based on virtual or physical machines' compliance with the configuration. Use Azure Automation State Configuration to host and manage PowerShell desired state configurations centrally. These configurations can be applied to Windows and Linux systems to enforce state configuration. Examples of configurations would include things like configuring applications and web services, enforcing compliance and security controls, and configure and enforce other operating system controls. Each API management pricing tier offers a distinct set of features and per unit capacity. For any exam, knowing all these capabilities is nearly impossible unless you just have a photographic memory, which I sure don't. I instead look at the outliers. Which things may affect an architectural decision if we didn't go premium? I'm linking the pricing tier and giving you a reduced table that I concocted from that same page. When you remove all of the ones that say yes across the rows, that big scary table in the docs page isn't so scary anymore. And now we've distilled out the choices that are most important from an architectural design. Another good chance to pause the video so you can review this chart. In this section, I'm going to reference a lot of what can be found on the exam objective page, aka.ms/AZ-305, at the bottom where they have the learning paths. Great material. Sometimes I like these and sometimes I like docs better, but for this first part, I'll summarize what's in there to save you some reading time. The migration learning path is actually tucked away under the Design Infrastructure Solutions grouping. You'll also find Design Network Solutions there also for our final part of this module. Both are linked at the bottom and also will be in my notes in the blog as I collate these links to share with you. The Microsoft Cloud Adoption Framework for Azure provides recommendations, best practices, guidance, documentation, and tools to help drive cloud adoption. And when it comes to an architecture/design exam, Cloud Adoption Framework is king. It's what we use in Microsoft Services quite a lot. There are 3 phases to migrate a workload in production: assess, deploy, and release. Assess your workloads to determine cost, modernization, and required deployment tools. After workloads are assessed, the existing functionality of those workloads is replicated or improved in the cloud. After workloads are replicated to the cloud, you can test, optimize, and document your migrated workloads. When satisfied, you can release these workloads to users. During this phase, ensure that you hand off the workload to governance, operations management, and security teams for ongoing support of those workloads. There are 4 patterns when migrating on premises. Rehost, also known as lift and shift. Refactor, an example, refactoring the code to a PaaS application. Re-architect, when they are not compatible with cloud. And rebuild, where an entirely new code base may be created to modernize the app that someone left behind a long time ago and it's just simply no longer supported. In the docs, they also have a 5th one for replace. The strategy you adopt depends on your business drivers and migration goals. You might even adopt multiple patterns so you can combine these together. For example, you might choose to rehost simple apps or apps that aren't critical to your business, but re-architect apps that are more complex and business critical. If you have worked on migration projects, you should be familiar with all the tools out there to assist. I'm linking this page showing you the table right now and will highlight the key ones. I would definitely want to know about this for the exam, and again, not the details, but which tool would you select to help with a particular part of the assessment. Pause this at any time to review the chart, but here are my callouts. Starting from the top, Service Map. It's real similar to the old map toolkit, but in the cloud, which will help to identify what you have and map any dependencies between those machines. Azure Migrate is the big machine out there. It can now also do the assessments across Hyper-V or VMware hosts and ultimately is the main tool to lift and shifting of the on-premises servers to the cloud. While Data Migration Assessment is now part of Azure Migrate and can perform assessments, the Azure Data Migration Assistant pre-existed it and is simply a standalone tool that can be used to provide database teams to run against their databases prior to any other activities done with Azure Migrate. The rest on the list are for monitor, optimize, and collect additional information before and after the migration. For this section, we have a lot of other modules that have been delivered to address much of this. First, let me share with you where you can find these. In my AZ-104 CERT session, Module 4, there is a section on Deploy and Manage Networks. If you're working toward the Azure Solutions Architect Expert certification, it also requires you to pass the AZ-104 to get your Azure Administrator Associate certification first. Even though the AZ-104 is not a design exam, getting or knowing these network fundamentals will help you architect a solution, which is what the AZ-305 is all about. And not to mention, you're probably going to need to know some networking in your career anyways. In my AZ-303 Module 1, Part 2, the second section of that video covers Implement Virtual Networking. This has the least amount of content, mainly only covering implementing VNet to VNet connections and VNet peerings. So if you don't know about those already, worth a review. Otherwise, you can pass on this one. And finally, in my AZ-304 playlist, Module 5, the second part is specifically on design and network solution. And since the AZ-305 is focused on architecting a solution, I would recommend at least to go over this video part. If you're rock solid on Azure networking, been there, done that, you probably don't need to review those. But again, if you're newer to Azure and Azure networking, then I'd recommend to review all 3 of those video playlists and review the Design Network Solutions Learning Path on the AZ-305 exam objectives page. Again, you can find that at the bottom of aka.ms/AZ-305. And finally, if you want to go uber deep on networking, I mean really, really deep, there is now an AZ-700 exam. I'd call this a pretty hardcore exam to peel out just one topic, a very big topic, for an entire exam. But then Azure networking has many, many facets to learn to get really good at it. The 700 review isn't necessary for the exam, but only if you want to be a SME in that area. Since you have some other videos and resources to view, I'm only going to highlight a few other points for this review, which may be different than what exists on other videos. To make this stand out a little bit more in preparing for the slide, I wrote out all of the AZ-304 exam objectives versus the AZ-305 so you can see them side by side and color-coded to match up the similar topics. Conclusion, what we did in the AZ-304 will cover most of what you need for this exam, as you can see side by side. You can ignore recommend a solution for automating network management in the AZ-304, as that is not on the left side for AZ-305. So what is left in AZ-305 that is not covered in AZ-304? Optimize network performance for applications. Therefore, let's explore that topic. Azure virtual machines have default network settings that can be further optimized for network throughput. How so, you ask? If your Windows VM supports accelerated networking, enabling that feature would be the optimal configuration for throughput. For all other Windows VMs, using receive side scaling or RSS can reach higher maximal throughput than a VM without RSS. RSS may be disabled by default in a Windows VM. RSS is always enabled by default in an Azure Linux VM. To determine whether RSS is enabled on a Windows VM, run the get-netadapter RSS command. If you see true, it's good. If you wanted to turn it on, you'd run the get-netadapter as shown, but that level of detail I don't think you would need to know. But knowing that you can enable the receive side scaling or RSS capability of a VM probably is noteworthy in order to optimize the application performance of a VM. Azure load testing is pretty new, so not sure if it will make it in this exam, but it sure fills this objective. Azure Load Testing Preview is a fully managed load testing service that enables you to generate high-scale load. The service simulates traffic for your applications regardless of where they're hosted. Developers, testers, and quality assurance engineers can use it to optimize application performance, scalability, or capacity. You can create a load test by using existing test scripts based on Apache JMeter, a popular open source load and performance tool. For Azure-based applications, detailed resource metrics help you to identify performance bottlenecks. Continuous integration and continuous deployment or CI/CD workflows allow you to automate regression testing. That's a wrap for this module and the AZ-305 CERT session. I hope it serves you well to enhance or accelerate your readiness plans to successfully take and pass the AZ-305 exam. It's been my pleasure to compile this information and these resources for you. If they help at all, please like and subscribe for more updates as we produce them in the upcoming year. Bookmark and share the aka.ms/YouTube/CERT URL to access all of our CERT channels. I'm Mark from Microsoft, and I'll be seeing you again on the next CERT session.